speech. The first one is by Yankai. The title is Automated Interactive Domain-Specific Conversational Agents That Understand Human Dialogues. The stage is yours.
Yeah, thank you so much. Good afternoon, everyone. So now we are talking about the domain-specific conversational agent, basically the chatbot. The agenda is like we first talk about the requirement of building a task-oriented chatbot, and then we are introducing the star framework we are using for extracting the knowledge from text, and the CASP, which is an ASP system that is directed by the predicate, directed by the goal, and then the AutoConcierge conversational chatbot, which is the example that we are using the star framework to build. We are talking about the architecture, the vocabulary, the CKT, the preference navigation, and some other details. Then I will give you one example conversation, like showing how this works, and finally we get to the evaluation. Okay, so I would like to ask you one question: how we build chatbots that are as good as humans? So our answer is like we should model chatbots after the humans, because we want let the chatbots interactive with humans. So we want them to think or work like human thinks. That is our principles. So how we do that? We think about the chatbots. They will listen to what the human user is saying, then extract the knowledge implicit in the sentence spoken by the human user. And also we will let them analyze the correctness and the consistency of this extracted knowledge. And this also will check if the knowledge is incomplete, like when you are filling a table. They like you said something is required but it's not there, then they're asking you to fill that, and also ask additional information for the human user if required. And then it will give the use the common sense knowledge to give the conclusions, which is then communicates to the human user. So this is the idea of how we want the chatbot like, and based on this, we designed a star framework to automate this, which are following these steps. First is automate the knowledge extraction from natural language sentences. And in the star framework, we will represent knowledge as predicates and use large language models for this extraction. And we will see how we do that later. And then we check the inconsistency, correctness, or completeness of the knowledge by the reasoning system, which we use ASP. And then we draw the conclusion from the knowledge, also using the ASP system. And finally, we transfer this conclusion, this predicate conclusion, to the natural language using the large language model. Again, so this is how the star framework look like. So actually, our group is exploring for a long time to seek a way to converting the sentence into the knowledge, and finally we found out the best way is to use large language models, and we believe that this is the best way to use large language models to be a parser. So maybe we can say that large language models are good language parsers. And so how does this knowledge extraction work? We will give the large language model a fixed vocabulary, which is the ontology we designed, and then we use the large language model to translate the meaning of the sentence in terms of these ontology terms to the predicates. I will give an example later, but now let's then discuss about how does the knowledge processing work. First, we express the common sense knowledge in ASP, then use CASP to process the knowledge. This processing of the knowledge involves checking consistency, computing the answers, and asking questions as I discussed. And we call this like a CKT step to asking the questions, and then if all the questions is required is satisfied, then we give them the conclusion. Yes, we call it a CKT. I will introduce it a little bit later. And then we use the LLM in reverse to generate a natural language response for the human user. So basically the structure is like this. First, we use the large language model as the input and output interface, and we reason in the median. Okay, so this is the STAR framework. And I also talk a little bit more about the sentence extraction, knowledge extraction. Yes, we use LLM as the semantic parser to extract the predicates or the knowledge from the sentence. The vocabulary is essentially an ontology used to capture the sentence deep structure, and turns out that and we did an experiment on that, and it turns out that a very small number of examples can help them extract knowledge from a sentence related to narrow domain. Like, I will show you one example we are doing. So this is about description of the restaurant. So the sentence, the feasibility coffee shop provide a kid-friendly venue for Chinese food that's average price point in the Riverside area is highly rated by customers. And once we give them the vocabulary, like say here, the vocabularies are the name, the type to eat, the cuisine, the price range, the customer rating, and family friendly. The LLM will generate the predicates like this. And you see that we also provide in the sentence saying that in the Riverside area, which is a position, but since the vocabulary itself doesn't have the positions ontology design, so it will not show up in the predicates. And also, if like we cut the sentence by here, saying that Fitzbilly's coffee shop provides a kid-friendly venue for Chinese food only, and then the customer rating and the price range would be also removed from the generated sentence. And also, like we can also do something like asking a question. Say this sentence said, "Can you find a place for food that at a low price? Both English and French cuisine is fine for me." Then the predicate is generated is like the name to be queried, the name of the restaurant is to be queried, and the cuisine type would be either French or English or French, and the price range is cheap. And we did this experiment. These are the examples from our experiment, and this experiment takes about accuracy at about 90%. Actually, for GPT-3 it's 89%, and for GPT-4 we tested it's about 92%. Yeah, so it's pretty high. And also, I will give you a brief introduction of the CASP system we are using for ASP. So it is an ASP system, and the difference from the Klingo is like it's driven by query. It's very like Prolog, so you can write Prolog like sentences inside, and with the default logic. So example is like this. And as it's a ASP system, it also supports global constraints. Like person can not be both sit and stand, or the multiple possible words, which is the local constraints. You can written as these things. So a person either sit or stand. Yeah, you can write in both ways. And another thing is the constraints in CASP is saying if you are querying for not px, then it will give you that x is less or equal to 0. Because we have the rule says px if x is greater than 0. And this helps us to query for the negation as negation as failure applies here. So this is about the CASP, a brief introduction of the CASP. And this is we are talking about the example of our chatbots. We call it AutoConcierge. Basically, it's chatbots that's recommending the restaurants nearby. So this nearby means we collected about 60 restaurants nearby the UT Dallas, or within the UTD's campus, and then we want the users to ask the bot to see whether which restaurant to recommend. So the structure is like the user says something, and then we generate the predicates from the GPT-3. And we also have applied a filter, which means that because the GPT-3's generation is kind of not under control, because they may hallucination or generate something that's very weird. Then you need to filter these things out. And then we are querying for going to check if they are querying for the displaying, which means looking for some history recommendations. And if no, you come into the this step. This step is for the generation of the recommendation. First is preference grounding, which is like you said, I like curry. Then it entails from the common sense knowledge that you may looking for in the restaurant or a Thai restaurant, and then we update the states, and then the CKT and the state completion checking. So if the information is satisfied, as we said, it's like filling a table. Like if the key information is missing, then the chatbot is going to ask about this information. And if all the required information is collected, then it search for the restaurant that satisfy all the requirements from the user. And if there is one, it says it's going to update the results and generate the explanation as well. Otherwise, it will tell the reader why there's no such place. And finally, these predicates are then turned into the English through this natural language reply generation step. And then we're waiting for the users to do another round of dialogue. So here I'm also going to talk about the vocabulary. Okay, so the vocabulary is like we are going to fix the vocabulary for both the reasoner, which is the ASP system, and the LLM. We design the vocabulary like this. We have the require, which is area of 2, like require for the food type as American, Indian, French, or we can also have the food type like coffee, the cookie, like kitchen as well. And establishment, which means whether it's a restaurant, a shop, or a bar, or something else, it's basically the type of structure. And then the price range, we have 3 levels, and customer rating, we have also 3 levels. and it also tells whether it's family friendly or not, or its distance, because the database is nearby the campus, so it has also 3 levels. In campus, nearby means about 10 minutes walk, and also in 3 miles. And we also have other, like the name, the address, the phone number, the menu, and so on. And also, another thing is the query. The query is the arity of 1, which simply says what you are requiring. Like if I said, what is the address of this restaurant, then it will generate query for the restaurant, query for the address. So these are the first shown up in the first level, like the food type establishment, so on and so forth. And also we have the prefer predicates, which is either a type of flavor, like we prefer curry, we prefer spicy, or like a type of food, like we prefer sushi or lemak. And also we have this another option, which means whether you are satisfied with the current recommendation and you doesn't satisfy with current recommendation and want another restaurant. And also like view the history, like history recommendation. And also we design the stank. Basically, if the stank is captured, we are replying you're welcome, something like that. And the quiz is like goodbye, have a good day, something like this. And irrelevant simply means if I'm talking about something that's totally irrelevant from the restaurant recommending topic, like you are seeking for a closed door or like a place to buy a car, then it will just reply irrelevant. Or you simply, so if the irrelevant is captured, it will generate like, sorry, I'm only about recommending the restaurant, these things. So, and we also have this, so then we'll talk about the CKT. The CKT is like, as I said, is very like state machine, and it's like the AutoConcierge to drive the conversation, and it captures the user's additional requirements and reason for the next state. So the next state means whether ask or to recommend. And then we have the preference-based CKT navigation, which simply says if you like curry, then you are either looking for the Thai cuisine or Indian cuisine. And also we set the priority of the preference, saying that we should always satisfy the requirement proposed earlier. We should always first satisfy the requirement proposed earlier. So it's like when you first time said I want this kind of cuisine, and then said I have some other preference, then the first said will be first satisfied, and if it doesn't satisfy, then we find another thing. And also there's the negation. Yes. And maintaining. So the negation is like we also design for not prefer, not require thing that's like. So not prefer curry means not prefer spicy means that I want anything but spicy. And not require the price range to be high means that anything but expensive. And okay. And about the explaining the recommendation. So it says once a recommended venue is generated, AutoConcierge explain the reason as well. And if there's no result, explain for the least priority requirement, where a result could be found once changed. which means mainly says what you should modify and to find the result. And then I will show you the interface. It's like when the guy said, I'm looking for a restaurant that serves curry, then GPT will generate require for name and prefer for curry. And if the reasoner generated the predicates like recommended Burger King, food type would be burger, and price range is cheap, and customer rating is high, then it will generate sentences like this. I would highly recommend you Burger King. It is an inexpensive restaurant serving for fast food, especially burgers, and has excellent rating from the reviewers. So this is one example of the conversation. What happened? What happened?
Oh, what the hell? Great. I have no idea what happened.
Maybe I just...
Can you unplug and replug your...
Okay.
Okay, that's an emergency. Can you rush to get somebody or do I?
Seems to have gone. ChatGPT doesn't want its secrets.
Oh, there we go.
Okay.
There's a power converter.
HDMI 1.
I got no idea. But the TV does have power. So that's
I
good.
tried the switch off, switch on method.
Okay. Turn it off and on.
Yeah, I tried.
We could try the other. If it's
Yeah, you should try a second time for sure. That's sometimes more
I got no,
statistics are
I got no idea.
side.
I just no idea. Zero idea. Okay.
But very few things left, just one example, and yeah.
I just got Sasha.
Okay. No. Well.
Said it should be here.
Okay. We're waiting.
HDMI to one, the source code one.
I mean, there
Try
can't really
HDMI too.
can't really switch on there because there's nothing plugged in. Oh. Yeah, that's good. So you're on one.
I think I'm in one.
Can you check your laptop if your settings are correct?
How do
Like that. And system, display, duplicate.
One
moment.
Yeah, it's not. So we're.
Let me check it. Let me check it.
Yeah, check.
The font looks like it might be kind of weird.
Oh well, there we go. That might be it.
Oh.
Is that?
Not really. I don't know what it's even doing. To be honest, this is weird.
The light should be on? Oh, okay, the LED's on.
That one's definitely on. Something like this is bound to happen at some point.
Yeah.
So, okay, but you can see here, right? So you're gonna go through the example, right? You're just gonna go to the demo.
So
You can explain the example and then go to the demo. Yeah, so you can just go through that.
Something happened. Step on that again.
I crossed it, I didn't step on it. But
You did.
I think maybe when you escape and then full screen again.
Yes.
You're detecting a second display.
Which one?
Are you detecting a second display in your settings?
Okay, we can try.
I'm just this is just I'm trying to diagnose what's going on here.
Okay.
Can you get to your display settings?
Go and, right? You know how you get you can see all the options on your.
You mean the display?
Yeah, display settings.
This one?
Yeah. Okay. Identify. Okay. This is. Okay, so it is detecting the other one. It's fine.
But actually, I can explain this.
So we just give them another.
Okay.
So, are you plugged in over there?
Yes, it's plugged in, and the screen should be duplicated. So
Yes. So, okay, then it's definitely on our end.
Okay. So I think it's laptop is fine. I mean, it was working.
can I unplug?
Please.
I think yes.
Yeah, now yeah.
So his laptop was working before. It just
His
went.
laptop's working before, which means that it's definitely on.
Blank colors.
Wait, did you unplug or did you still plug in? Somebody unplugged. Okay.
You have it on the power, right?
Yes. But I think like this.
Oh, there we go. And it was there for half a second and then it died.
Half a second.
We just make this a speak.
Maybe it's the cable. It's interrupted the cable. Can I unplug?
Yeah.
Try to do less movements here. Go straight.
Okay.
Because maybe it's interrupted the cable.
Ah. So it's like tangled.
No way.
Any luck?
Oh. Oh.
Yeah, sure.
Thanks so much.
Thank you.
This is good? This is what you want?
Right.
Okay, good.
So you want to show your previous example?
I think I should.
This is basically the whole, this is
That's showing correctly.
Yes.
Okay. So this is one example showing here, saying that. So it's like, hi there, how can I assist you? And the user says, can recommend me a restaurant. From there, the required name query, required establishment restaurant is generated. And then said, is there a particular type of food you would like to eat? It's like asking a question because they have, the user originally have no requirement of the restaurant, so they are looking for what type of food do you want. And the user said, I can try any food except curry. Then says, not required, the food type of Indian would be added to the states. And then the bot is checking, okay, you got the food type and anything but, oops.
Okay. This video again. Maybe, yeah, let's try this one. Hopefully this one's not bad.
Good point, yes. Okay, so. Junior, there are a couple of. Other people started taking some negotiating that as a 0-2. So
This is not the adapter.
this was a teaching 2 courses in the spring. You got leaves in the fall. Right. These are like another year's house, like all the courses that you were supposed to teach on the rest of the part. And that was sort of like the back.
So,
But if you 0 for 4,
they can yes, I'm going to run a different adapter.
I have no idea.
I'm gonna go run back and grab
The
it.
British University is hiring a higher schedule, right? So you could have recently
Video is online.
No, the video is local.
Video con open.
So I don't think.
Oh, I also have an online version, but I need to find one.
Maybe you can change this, then you comment the video
I can send you the link.
to the guy.
Okay, yeah.
pretty
Okay.
quickly we find out in 3 months that it's very nice that you did before.
That is hard for me to really understand. But
Yeah, no, my at this point, I can be.
I don't know, it's show you one thing, it seemed like it was much more like I'm surprised he was sort of ready to do his research program already. Yeah, I know he has to have a couple of kids, so maybe we just didn't plan to do that. They were sort of coming, because his wife works for Cisco, which is very well paid. You're supposed to do this. I'm surprised it would already be upset with clothing.
Living in Australia and teaching in London is like, are you?
Yeah, there's a.
Yeah, and what is
Take next page.
Okay,
Don't forget.
Yeah, where'd you do? How do you need to? Small town life, but that's where I'm supposed to. I don't know.
Yes, if you want to.
UMass.
And guys are going to do it off. So you just.
You came in to Spanish, like, every kind of thing. Island, you know, sort of like, sit at my desk and do my work, and, you know, I actually got into close to an argument with my point because we were talking about like screening the guy on the evidence. And he said, oh, I don't want to be on interviews for candidates who aren't in my area, it doesn't help me. And I'm like, if you just be heard, it doesn't come forward. If we don't take the manager, then the rest just take over.
Okay, here we go. Go back, just go back. Okay, so I think we just.
Okay.
You may unplug and.
Okay. All right, I think you just show your demo now, yes.
Didn't work quite so great last time.
Okay, so I'll show the demo. Like, it's a little bit small. Font is a little bit small, but I will read it to you. Okay. So first you run the program and Bart will say, "Hi, how may I assist you today?" And imagine that you are coming to the front desk or like a bot that's standing in front of the the hotel or something else, somewhere else, you just speak, hey, I want to celebrate my son's birthday this evening. And the semantic extract is like the requirements of the special. We require to find a restaurant and it's family friendly. And it will reply, all right, a family friendly restaurant it is. Do you have a particular cuisine in your mind for the venue? And the user might simply say, I like curry. Then it will generate prefer curry. And the bots reason and reply, so you prefer curry, understood. Do you have a specific budget in mind for the venue? So then it's asking about budget. And the user just said, I have enough money. And it generates the required price range will be anything. It simply means it can be any level. Then it's come to a next round of reason and said that the price is not an issue. I see. Do you have a specific preference for the customer review of the location? And I think the user just said, make it highly rated place, please. And the extracted predicate from here is query for the name and require the customer rating will be high. And then it's thinking about a result.
So it's now computing the result, so that takes a little bit.
Yeah. And I would also say that one feature is like the bot, because we're using the GPT series as the interface, so it understands the human's utterance. Like if I just said I'm a student, then they will say, okay, the price range you're looking for is cheap or something else. Yeah, they are understanding the implicit meaning of behind your words. Yeah. So there is the recommendation. It says, okay, a place with high customer ratings. I suggest trying this pizza and grill. Is an Indian eatery perfect for families known for their specialty in curry dishes. They offer affordable prices and hold high customer satisfaction ratings. Does it appeal to you? And you said, that is pretty good, but do you have any other choices? So they extract the meaning saying that, extract the knowledge that you want another option. And they are recommending for another one, saying, sure, I'm fine, I will find another option that meets your needs. I was suggest trying out Thai this kitchen. And this family-friendly spot specializes in Thai cuisine, particularly curry, and is moderately priced. I also boast high customer reviews. It also boasts high customer reviews. That sounds appealing to you, and the user says this one looks more appealing. Where is it? Then it's capture the address and gives the address. So it's like this is a demo for that.
When it says it specializes in curry dishes, where is that stored in your database?
We are collecting from collected from the Google Map, saying we are collecting the stores, the restaurants, and with their informations basically. And
we didn't just say predicates that would say this place.
So we're giving the context also, so it knows that we're looking for a curry dish. So essentially, it collects the predicates that are relevant to the answer, gives it to GPT-4 and says, give me the corresponding sentences, and then it generates.
So it's hallucinated that their specialty is curry dishes.
Well, it asked for curry.
Yeah.
Preference. The customer earlier
The customer asked for curry, but does it have any knowledge that this place is especially good at curry? It knows the cuisine, but it doesn't know anything about this place specialized in curry, other than the cuisine.
You could say that, yes, it hallucinated. I mean,
Yeah, so it's
there
made
in the
up
context.
information it doesn't know. Interesting.
So it's there in the context,
No,
but it's not clear whether it came from the context or it just came from somewhere else. Yeah, you're right, that way.
But we'll know for sure it didn't come from your database, because your database doesn't have that information.
No, but the context has, so he's also passing the context, saying the customer preferred curry.
yes.
Right, but that,
So that context might make it say that this place has wonderful curry dishes.
yeah, no, I understand that.
Yeah,
Right.
and this information is collected from the internet.
No, why is it hallucinating? Because the customer said, I preferred curry, he passed that information
But
to the
you're
LLM.
saying known for their specialty in curry dishes. It is not known. It's making that up. It's a great phrase to use. It's the sort of phrase you find in this context.
Okay.
Which is why ChatGPT
Okay,
does it.
yeah, sure, you could
But
say.
it doesn't know that.
Yes, that it is known. So the question is the restaurant specially known for, is that coming from somewhere or just made it up? I think you're right, yes, it kind of made it up, yes, yeah. Makes sense, yes. It'll be impossible to tell. Because his information is coming from a database of restaurants. There is no descriptive information or anything about that restaurant, right? All you have is a table of restaurant, their address and their specialty or something.
And what type of cuisine they are serving. Yeah.
And what type of cuisine, but but that information that it is specially known for curry is basically added by the LLM.
No, speciality for curry. This implies from the
No, but the phrase what Phil is saying is specially known for curry, because that is too specific.
Oh, okay.
That information is too specific.
Yeah, then you can say that, yes.
Okay. Yeah. So the phrase that it specializes in that. we
Right,
don't know.
that is
Yeah.
hallucination. But sometimes the human will also they are extracting for what they are famous for, but exactly.
This is not a criticism of your work at all. I really like your work. It's just a criticism of
Yes,
ChatGPT.
that is.
You know, you have to be
Right.
further if you wanted it not to make stuff up.
Yes.
So, but in this case, it works to the advantage that
It sounds
makes it
right,
sound
yes.
more convincing.
So I think the evaluation part, I just quickly go through that. We did the efficiency evaluation and human evaluation. We compared to PPTOD, which is a end-to-end transformer-based chatbot, and the result is it's outperforming especially in the truthfulness and coherency, is really higher than this one. And now we draw the conclusion about. So our philosophy of the design is to emulate the human level intelligence, mimic a human, and we use the STAR framework, which use LLM as the language parser and the ASP as the backend reasoning engine, and we apply this framework to an example called AutoConcierge. It collects the user's preference for food and restaurants and give the recommendations. It has a fixed vocabulary so that everything is certain, and you can never say something out of this vocabulary. And we have the preference navigation, and it ignores the irrelevant utterance. And we also allow the CKT, which is to let the bot guide the conversation, drive the conversation basically. And we also check the consistency, and in this way it outperforms the ChatGPT because ChatGPT can generate something hallucinated. And so for this bot, it ensures the truthfulness and avoid hallucination, and actually it's not totally avoid hallucination, because in generating a sentence, the ChatGPT, it will write something that is not very real, but the information provided is true, basically. And the response in the reasonable time. Okay, I think, okay. Yes, and we compare to the state-of-the-art deep learning only models, and Yes, and find it's better than that. And one thing I should mention that is its main limitation is the scalability, because it's only for one specific domain. Otherwise, the vocabulary is really huge, and you cannot process that long vocabulary in any even in those ChatGPTs in context learning, they are not allowed you to get this many vocabulary, and also it's task specific. Yeah, this is what I want to share with you today.
So
Thank you so
let's
much.
thank the speaker. So we had a few technical issues, but let's take 1 minute for a quick question, please.
Hi, so you use in-context learning to sort of prime the language model to generate the vocabulary. So how difficult, I mean, so you said it needs very few examples, but how much effort went into sort of crafting doing the prompt engineering to get the right examples, and how much do you think that would generalize, for example, to other domains of, other domains that you might have chatbots?
For this example, I only first telling what the vocabularies are, and if for some predicates, if it's not that obvious, like the establishment, which like you cannot, it doesn't that obvious to the ChatGPT, then you just should write a small description of that, and then like you are giving the examples just following this format, and they will, the examples are only for formatting the the output format, So for this example, we only generate like 11 examples.
So for each predicate, maybe 2 or 3 examples.
Yes.
Essentially, so it does a good job of that.
Mm-hmm.
And then, if it makes mistake, you could give more examples and try to bound the. But the main thing here is that we're defining the predicates, and the challenge would be: can we take a large ontology and use that as the knowledge base? So that's basically ongoing work. Or also, can I train this chatbot automatically, for example, to also give directions to the airport? So how to do that out? So those are some of the things that Yankai is working on.
Yeah, we are still continuing working on that.
Okay, I think there was another quick question on this side.
Yeah, I was also going to ask about the prompt engineering stuff to get the predicates from the user input. I had a quick look at the paper. I didn't see like some concrete examples of what the sort of prompts you used were to get the predicates out. I just wondered if they were available anywhere, because it seems like that's quite an important technical detail.
So can you maybe show it on the slide? You remember you had two examples.
Yes, but I think he's talking about the true context we're using. Yeah, I'll give you. Where it is?
While you're looking for one very important question, what does STAR stand for?
Also, STAR is it's a framework that we designed for exactly this kind of thing, for extracting predicates from. And I don't remember what does STAR stand for. Semantic.
I also don't remember.
But it's another paper where we use this technique of extracting knowledge for other applications as well.
So the examples are given like this. So we have this sentence, and then we get an arrow for that, and indicate the predicates column these things, and then we follow these structures. And but to the top, we are giving the vocabulary in one line, and then we provide these examples in these pairs, and then we give, like, let's say, saying that this is what you are now trying to find out for the predicates. Yes, basically like this.
So for example, you could say Fitzbilly's is a kid-friendly venue, and then you could give pound sign and family-friendly yes pound, and that's more or less.
So there might be like 20 of those, and then
Yes.
user input,
Yes.
and then you have like some other prompt, and then it fills in.
Right.
Yeah.
Right.
And also for the, as you mentioned, for the prompt engineering, we might figure out what place or what examples it doesn't work very well, and we should add some more examples on that. This is also like, yes.
Okay, sorry for interrupting, guys. I think we have time at the break for continuing the discussion, so let's thanks again the speakers.
So we'll be making code public, I guess, soon. So
So let's try to move to the next.
It could be sensitive.
absolutely.